we're actually going to look at alternate segment theorem as well as the tangent secant theorem. Last two theorems that you need to know. Alright, on top of all the other things. Okay, so you need to be able to prove that and then use them to solve some practical problems. Before I start going into the theorem, I would like you to know a couple of things. The two words that I want you to know is circumscribed and inscribed. So, I think you've come across those two words before, but just to reiterate it. Circumscribed literally means to draw around. So you've got a circle that's circumscribed around the triangles. You can see that the vertices are actually touching the circle. And this is a regular pentagon. You can see that a circle is circumscribed around a regular pentagon. So for example, a cyclic quadrilateral, it is actually circumscribed around a circle. I'm sorry, a quadrilateral is circumscribed around, the circle is circumscribed around the quadrilateral, alright? Let me repeat again. For a cyclic quadrilateral, a circle is circumscribed around a triangle. Whereas inscribed means to draw something inside something else. A circle is inscribed in a triangle. You can see the side is touching the side of the triangle. Same with that. A circle is inscribed a regular pentagon. Right? So you need to know these two words. What does circumscribed mean and what does inscribed mean? The reason I'm doing this is because when we look at the next one, alternate segment theorem, you need to know that this the circle is circumscribed around the triangle. Alright? The angle between the tangent and the chord for this theorem, the angle between the tangent and the chord, chord AT, is equal to the angle in the alternate segment. So this is the angle in the alternate segment, and this angle is the same as that angle. So you need to know that. So we need to really prove that angle TAB is the same as angle BTN. Alright, how are we going to prove it?
So,
Yes?
if you extended the tangent on that slide,
Yep.
would that other angle be equal to B?
Which one? This one?
Yeah.
Yes, equals to B, that's correct. So if I extended, very good, thank you. So if I extend this out, this angle alpha, this angle will be alpha. Alright, so it's what you can see that this is the angle sum of a triangle, and this is actually a straight line 180 degrees. Yep. Let's continue on. Alright, let's prove. Required to prove BAC equals to BCD. Alright? BAC is equals to BCD. Alright, the A is there. It's too close to the text there. But it's okay. Given that DE is a tangent to the circle with the center O, ABC is a triangle circumscribed by the circle, and point C touches the tangent. So you know that these 3 points touches the circle and point C touches the tangent. How do I prove that this angle is the same as that angle? Anyone want to venture a guess? What do you start off with? Yes, John?
You construct lines OC and OB.
You construct OC and OB, very good. So, construct OB and OC and actually let angle BAC equals to theta. Instead of keep on writing angle BAC, I just assign it with one angle, whatever it is, theta, alpha, gamma, whatever you want to call it. Alright? So once you've done that, what's next? The next thing you need to do is you would realize that the angle here is twice the angle there, correct? Yeah? That is what we've learned. So angle DOC is 2 theta. Angle at the center is twice the angle at the circumference. Once you've done that, what's next? What's next? You need to use some other information that's given. You've got that and that. Yes? Very good. OB is equals to OC, which is the radii of the circle, and therefore you know that these two angles are the same, right? The base angle of an isosceles triangle. Excellent. So you can work out OCB. So you know that that's 90 minus theta. So see, the explanation is a bit longer here because I need to say that that is the radii of the circle, and therefore OCB is isosceles triangle. That sentence and this follows from that sentence. Or you can say OCB is an isosceles triangle because OB equals to OC equals the radii of the circle. The same as well. And then state that OCB and OBC are base angle of triangle OCB. Right? So once you've done that, the other thing you need to look at is what I taught you yesterday, which is the angle of a radius and a tangent. What is that? 90 degrees. So that angle is 90 degrees. BCD equals 90 minus OCB equals to theta. And that's the angle between the radius and the tangent is 90 degrees. And therefore, we can prove that BAC equals to BCD QED. So this is the way that you prove. I mean, you need to learn how to construct lines. You need to learn how to assign angle. Sometimes it may not be, it may not be necessarily to assign an angle. You can just use angle BAC. If it is not complicated, sometimes you have to because the proof goes on very long and probably it's easier to do that. I'll show you an example tomorrow, all right, where I will assign an angle, a particular symbol, and then we'll follow through, rather than just using angle BAC all the time. All right? This one is pretty straightforward. If you want to use BAC all the time, that's all right as well, but I wouldn't bother. Now, all right, we've spoken. We've decided, the three statisticians decided that yes, we'll accept things like angle theorem or whatever, the name of the theorem, as a proof, rather than writing all this out. I'm still writing all this out. For example, angle between the radius and tangent is 90 degrees. But if you can remember that theorem, write a theorem. Alright? So you can use alternate segment theorem, or if you want statement to use is the angle between the tangent and the chord is equal to the angle in the alternate segment. You can either use that or use alternate segment theorem. We'll accept that. Basic reason is next year you don't really have to remember all these theorems. You just need to be able to apply them. Right? So I'll be happy to accept alternate segment theorem for the proof. Alright, let's follow this one up with some example. Let's do example 1. Alright. Given that EF is tangential to the circle with the center at A, CBD equals to 50 degrees, 55 degrees, and DBF equals to 60 degrees, determine CEB. What I always like to do when solving problems like this, I like to annotate the diagrams. Make it a little bit easier. I'm a visual person. I like to see that. And I'll suggest that you do that as well so that you don't get confused by angle CBD. Sometimes when I was reading, when I read questions, I actually, occasionally I get mixed up when I wasn't paying a lot of attention. So you got to be very careful, annotate on the diagram. It actually makes it a little bit easier, in my opinion. So there are 2 ways of doing it. All right? I will show you one way, and then I'll talk about the other way. So one way of doing it is using the idea of this, the alternate segment theorem. This angle is the same as that angle, correct? And therefore, you can work out the missing angle by using angle sum of the triangle. That's one way. That's how I did it. So I wrote down BCD is 60 degrees. And of course the explanation. And finally, CDB is 180 minus 60 minus 55 degrees, which is 65. Angle sum of a triangle. Or the other way of doing it is use this line. You know that EBF is a straight line, it's a tangent, so this 180 degrees. Work this angle up and then use this angle segment theorem and say that. That's fine as well. So there are many ways of doing things, 2 or 3 ways. So as long as it's logical and it makes sense to me, you'll be fine. Alright? So pretty straightforward this one. Let's try the next one. Determine the value of x plus y. It's not x and y individually. X plus y. What do you need to do? You know that one of the angle given is 30 degrees. Now in this situation here, what is important? This line and this line, I should let you know that it's actually the tangent to the circle. If it's tangent to the circle, what is the significance of this? Yes?
X and Y is the same value.
X and Y are the same value. Yes, that's true. And how do you determine Y? That's good. That's one point. What is the other point? Yes, Leila? External tangent. So alright, these two will be the same angle and also that because that is an isosceles triangle. Correct? From one point, remember the tangent touching the circle from the same point, they are the same length. So many information that you could use. Y is equal to 180 minus 30 divided by 2, 75 degrees. And the explanation is tangent from a point to a circle are equal in length. Therefore, y is one of the base angle of an isosceles triangle. See? This line is the same length as this line. So this is an isosceles triangle. So y is 180 minus 30 divided by 275. And then since x equals to y, therefore there's 75 plus 75, 150 degrees. X plus y. Yeah, you all get the idea and know what to do. It's just the logical step. Next, before I continue with the next theorem, I would like all to remind you the difference between a chord and a secant. Alright? Chord is a straight line that connects 2 points on the circumference of a circle. That's a chord. A secant is a line that intersects a circle exactly at 2 points. 2 distinct points. Alright? So this is a secant. And it's actually, you can see that it's an extension of a chord. So you need to know that when you solve problems with the secant, sometimes you might need to use the idea of the chord. Because a secant is just an extension of the chord. Right? So that's the thing. Sometimes if you look at a problem, I have seen people not really know what to do because they couldn't put the idea of a chord is part of secant together. So you need to realize that. Therefore, this slide. Okay? So the next theorem, tangent secant theorem. When the secant and the tangent are drawn to a circle from an external point, the square of the length of the tangent equals the product of the length measured to the circle on the secant. Big words, long words. But basically it means this times this is the square of that line. Alright? Now, when it comes to this sort of situation, to prove it, what comes to mind straight away? What should you use? Sorry? Pythagoras?
Similar triangle.
Similar triangle. Not quite Pythagoras' theorem because you are not using 90 degrees. Similar triangle where you have the ratios. So you can see that I will have to draw two triangles in there. It's how do I do it, that's all. So let's have a look at the proof. I'm using the same diagram. Alright, you now require to prove AM times BM equals to TM squared. Given that TM is tangent to the circle and ABM is the secant of the circle. Alright? What sort of lines do I need to construct? Make it into a triangle. So, two triangles actually. Construct two lines BD and AD. Now, I've got two triangles. If you look at this triangle here, you will know that this would be the common angle. Right? So therefore, you are looking at two similar triangles. I'm going to just highlight this for you first. Because M is a common angle. And the other one is not TAB. The other one is this one. Alright? Yeah? This one what you want to prove. You're not using the two small circles, you're using one small and one large circle to prove that they're similar. Basic reason is that is a common angle. Alright? So of course there's a common angle as well if you want to use that, but I'm going to use that angle as my proof. Right? So I'm going to start off with stating a few things. Alright? TAM is actually the same as BTM. The alternate angle, the angle in the whatever it is, the alternate segment theorem. Right? So that's the first thing. This angle is the same as that angle. Right? Agree with me? Now from there, the other one is the angle M, their common angle. So this one here is a common angle. So therefore, what else? What else will be the same?
Angle B.
Yes.
Also angle MBT and ATB.
Yeah, very good. MBT and ATM, because we're using a large triangle. It's the same, the angle sum of the triangle. And now state that TAM is similar to BTM, angle. Alright, write the ratio. I'm not going to write the ratio for you. You write the ratio out first. And you write the ratio out first before I show you what I've done. This is the ratio. BM over TM equals to TM over AM. Corresponding sides in a similar triangle. In similar triangles have the same ratio. And automatically, you know that AM times BM equals to TM squared. This is the proof. When you do your proof, it's step by step. Always, once you have something square, it's always either a similar triangle or a congruent triangle, because you want to get a ratio and multiply them together. Okay, that's one trick that you need to know, and you need to know that sometimes you really have to start thinking about isosceles triangle using the radius. show you some example tomorrow, solving problems. Okay, if you use this, just use the tangent secant theorem. It's so long to write it out, just use the tangent secant theorem. So from now on, you can just write the theorem when you're proving. Last question. All right, AD is tangential to the circle shown below. C is the point of the circle such that CD meets the circle again at B. If CD is 22 centimeter and AD is 10 centimeter, determine CB. So you do know that in this situation, CB times CD is AD squared, right? CB times BD, CB times CD, sorry, equals to AD squared, using your tangent secant theorem. Let's try that and see how you can determine the length of CB. As long as you don't make a mistake like me when I first look at this question, instead of using 10 centimeter, I use 100 centimeter. And I was looking at my solution, I was like, wow, couldn't be that. Until I noticed myself putting in an extra zero. Yes?
So isn't it CD times B?
Sorry?
Isn't it CD times B?
Oh, BD, that's correct. Yep, my fault. It's BD, not CD. It's CD times BD. Yep, that's better. CD times BD. Yeah, if you just write that down, CD times BD equals AD squared is a tangent secant theorem. You should be able to solve it. Substitute the values in, and I would say 2 decimal places will do. All right. Remember your units right at the end. So basically, after this lesson, I've introduced all the circle geometry theorems that you need to know, and we can start combining everything together and solve some problems. And I'll show you a few more problems tomorrow, about 5 problems that we'll solve together.